Hello everybody. Welcome to Python lesson 3, which is about pandas. Okay, let's get started. Before anything, let's see what's gonna happen in this lesson. In this lesson, we are gonna talk about series and data frames, the basics. We're gonna talk about reading and writing files, dealing with missing data, dealing with categorical variables. We will talk about merging, uh, joining and concatenating data frames, and at the very end we are going to talk about uh, multi-column, and we are going to talk about a little bit date time and then pivots. Okay, so if you have Anaconda, install Pandas by going to your Anaconda prompt and by typing conda install Pandas. So just here you can type Anaconda prompt, open it up, and then all you have to write is to just type conda install pandas, and then hit enter, and then automatically, it's going to take a few minutes, but automatically pandas will be installed for you. Now I do have a panda already, so I don't have to worry about that, but so, and then you gotta say import pandas as PD. Yeah, so we do that one, and then the same comes from the name comes from panel data. So panda comes from panel data. If you have not done the following, go ahead and do it. Import pandas as PD that we just did. We'll talk about the series and data frames a lot. So we are going to start with series, and we'll see what's a series. A series is a one-dimensional array of information organized by an index. The biggest difference between a NumPy array that we saw in the session 2 and Pandas series is that Pandas series can have a named index, and we can call values based on that name. Okay, let's start with different ways that we can create series. We want to see different ways that we can install series. Okay. And I'm just reinstalling pandas to just show you what's going on and how it will goes, but essentially I didn't have to. Okay, here I have a list. Okay, so now everything is okay. My pandas is reinstalled. I close this window, so, and I run this. List 1 is a list of 4 numbers. Is 4, -2, 16, and 0. And then next line I have, I'm defining a series. I call it ser, and the way I create that is pd.series with capital S, and then in parentheses list 1. If I run that, and then I do the ask for series, I see this. So it has, as you can see, it has a index 0, 1, 2, 3. So I have 4 items there, and they are 4, -2, 16, and 0. And I can ask about type of ser, and pandas is gonna type, sorry, I have a, okay. And if I run this, as you can see, it's a pandas.core.series.series. So it means it's a series. Okay, Now let's have another list called labels. If I run that, I have this list, and then I can have ser1, which is pd.series in parentheses data equals list1 and index equals labels. So it has two components, data and index. And now if I run ser1, you can see that here rather than 0, 1, 2, 3, which was like these indices, they were automatically generated. But here I gave them names. It doesn't have to be A, B, C, D. I could just call them, one of them, I don't know, A, then next letter is, for example, Y, and then next letter is like C, T, and then I don't know, like something like this, D, H, P, let's say. And still it's exactly the same. Here, ser1 has these names, A, Y, C, T, D, H, P. These are just labels, yeah? What's the point of having index? You can call items off of a series by index. So for example, here you can either call them like this, and the third item, which is 16, you can say ser1 in brackets 2. Okay, so when we have this series, let's take a look at ser1 one more time. This is ser1, and now out of this we can, as we had in the case of lists, we can have something like this, ser1 and then inside brackets 2, or we can call item index 2 with the name of the index, which is CT. Okay, so we can call this. Now, okay, let's have another series. Let's call this maybe okay, ser2. Let me before that, let me change the ser1 labels back to what we had, or I don't have to. I can just ignore that one, but let me change this to what we have in ser1. So this is going to be Y, and then CT, and then DHP. So I'm going to create another series, ser2. This is ser2. Same indices, A, Y, CT, DHP, and then values are 40, 50, 60, 70. Okay, so labels can be just one letters or multiple letters, whatever. Now let's see, out of this, for the first time I want to introduce a new subject called data frame, combining two series to a data frame. First we create an empty data set, so I call it df. It's df equals pd.dataframe. Keyword is data frame here, and then dfa, and then b, and then df head. So here we have two columns. Again, A and B here are just arbitrary. I don't have to name these A and B. Or here I didn't have to name them, obviously, A, Y, CT, DHP. These are just arbitrary labels. I could just call them A, B, C, D. So if I can this easily create a data frame. So first I created the empty data frames, and then df in brackets capital letter A equals ser1, df capital letter B equals ser2, and then with that I created data frame. I can take a look at df head, or like if you take a look at df itself, is the same thing. Yeah. Okay, so far we talked about series and data frames. Let me maybe change my labels to the initial thing just to avoid confusion. So let's just call them A, B, C, and then D. It doesn't matter whatsoever. But okay, you can even pass on non-numerical objects into series. For example, ser5. Here I have 5, -9, letter F, and then number 2.4. Take a look at series 5, ser5, and the type is series, but you can see labels are now ABCD, but values are, this one is -9, this one is letter F, this one is 2.4. Converting series to data frame, it's very easy. For example, I can create this DFI, and it's just a data frame out of series. So DFI is going to be this, and I can give it a name. So here, as you can see right now, DFI, this column has name 0, which is automatically generated. If I want to give it a name, it's going to be something like this. So it's going to be ser5, comma, columns equals C1. And then DFI, it's going to be something like this. And the type is data frame. It's not series anymore. So with that, I created a data frame. So data frames, let's revisit this subject. A data frame is multiple series that share the same index. It can be only one series as well, but usually it's more than one series. It's multiple series that share the same index. So that's why, like, when we have like these labels for ser1, I use these labels. For ser2, I used the exactly same labels, and then I was able to create dataset df that labels were shared between series A and series B. It is two-dimensional, size mutable or changeable, potentially heterogeneous tabular data. So heterogeneous means you can have different kinds of data. You can have strings, you can have floats, integers, everything, even a Boolean. Very similar to a CSV file or an Excel spreadsheet. Okay, one common way to create a data frame is to create a data frame off of a dictionary. Let's have an example. Here I have a dictionary inside parentheses. This is a dictionary, yes. And then off of that, I create a data frame. So here, let's run it. And as you can see, this data frame has 3 rows: row index 0, row index 1, row index 2, and 2 columns, column A, column B. That's one example. Another example, I'm going to create this math. So you can take a look at math here. It's a random normal. I'm creating random numbers. I have 7 rows and 3 columns. It's 7 by 3. It's an array or a matrix of 7 by 3 of random numbers from normal distribution. Let's convert math to data frame. All I have to do, because I already have a matrix of 7 by 3, I can create a df1 by just pd.dataframe in parentheses math. Take a look at df1. You can see here you have names labels 0 to 6, again automatically generated for labels, and the name of columns are 0, 1, 2, which is again automatically generated. You see, Pandas automatically assigns column names 0, 1, 2. We usually don't like that. Let's be a bit fancy and have our own column names. So method number 1 that we can have our column names is just call the data frame, which is df1, then dot columns, then equal to, and then whatever you want. So ABC. Now take a look at df1. You can see the labels are 0 to 6, and name of columns are A and B and C. Number 2, we could start from scratch. We didn't have to do it in 2 different stages. Something like this also works. Yeah. You can see that now we have different numbers because we generated those numbers again. We can also have an index column. So these columns, rows they can be named 0, 1, 2, or like each row can be named like 0, 1, 2, 6, 2, 3, 4, 5, 6, or I can just give them names. That name for each row is called index. So df3 is something like this. So again, I'm using math. So here I could use this, or I could just say math if I wanted the same thing. So if I do this, this is going to be df2, and this is going to be df3. So now each row has a name, A, B, C, D, E, F, G. Now again, the names don't have to be A, B, C, D, E, F, G. It can be like multiple letters for one row or something. Just for the sake of simplicity, I call them A, B, C, D, E, F, G. You can also use split function. Just rather than saying this, you could be fancy and then just have index equals A, B, C, D, E, F, G in quotation marks and then dot split. It's exactly the same results. Converting a data frame to NumPy array. So we saw how we can convert a NumPy array to a data frame. How about the other way around? Can we do that? Of course we can do that. How? Very easily. R equals df values, and then take a look at R, and that's going to be our answer. So this is like what we have, what we get for df. So to just remember df was this, 2 columns, 3 rows, and we just converted that to a matrix with these AR equals df values. Okay, another one. Now let's move on to a little bit more complicated data frame. df4. df4 is a little bit more complicated data frame. Let's see what we have here. We have 4 rows and then 4 columns. Columns are name. So again, I'm creating a data frame off of a dictionary. Yeah, this is a dictionary. So column 1 is name, and then you see the format, name, and then colon, and then Surush, Jamie, Kiana, Arash, in quotation mark, dot split, then height equals, here I have a list, and then here for age I have this, a list, and then for field I have a list, and so I have 4 lists for these, and then I have 4 rows and 4 columns. Now if I want to take a look at df4, df4 is something like this. It's 4 human being, We have data on their names, their height, their age, and their field of study. Now that's df4. Let's do df5. Let's say df5 equals df4, and then if I do that, then let's say for some reasons I want to, like, after 100 years, or let's say after, I don't, something like that, I want to update that. So I say df5 age equals df5 age plus 100. If I do that and I take a look at df5 first, if I take a look at df5, you can see their ages are gone 100 numbers up. Yeah, but we expect this change to happen only on, or we want this change to happen only on df5, not df4. But as you can see, df4 is also affected. So this is the same thing that we had for arrays. Yeah. So we have the same problem as we had with arrays. You see the problem with df5 when we change df5, df4 also changed. So if you don't want this, you have to just do a little bit trick that we had before. So again, I'm creating df4 exactly as before. Then if you want to make df5 independent of df4, you have to use dot copy. So df5 equals df4 dot copy inside, and then parentheses. And then if you make a change in df5, you can see that df5 has been changed. Oops, sorry. df5 has been changed, but not df4. So df4 is like original, df5 has changed. So if you want to keep the original, which is usually the case, you gotta use dot copy. In this way, you haven't changed the original data frame df4. Now you want to restore df5 without going all the way to the beginning. So if you want to reset df5 to df4, now all I have to do is to just say df5 equals df4 dot copy, and now df5 is resetted. Okay, renaming columns, how to change the name of the columns. Let's say you have a data set and then you want to change the name of each column. What do you do? It's a very good question. So for that, I'm going to create this data set df. You will see we have 3 rows, 0, 1, 2, and we have 2 columns. Old name, columns have old name 1, old name 2. So now we want to rename them. df.rename, we use this keyword, df.rename, and then inside parentheses, columns equals old name 1, whatever I had before, and then colon old name 1. So here I have a dictionary, as a matter of fact, and I use that to rename that. When you run this, you can see this, but have you made any changes in df itself? If you run df, you see the df is as before. You see this is, I ran df, still the name of columns are old name 1, old name 2, which is not desirable. How can I resolve this issue? As before, use in place.true. If I do that, then the problem is solved. df. Now df is no. Or another way you can do that. So let's get back to df. This is df now. Another one is to just say df equals this guy. And then check df. So if I say that and then check df, that also works. Yes. So this is the second method. Or equivalently, I can use this. Okay. Selecting rows and columns. We saw how we can select a couple of rows and columns in arrays. We want to do that in data frames. So let's say that again we have that math. I can create it again with different random numbers, and the data set df is again as before. And then here I have a data set of 7 rows and then 3 columns. Selecting a column, 2 methods. Method 1, name of the data frame dot column. It's very similar to what we have in SQL language. So df.a, you can see that you got just the column 1. It's just column 1. So df dot name of the column. Not a good method. You might mix it with built-in functions. A better way, a more clear way is this one. We always use this one. df, then in brackets, the name of the data set. This is definitely better. Let's check this, its type. You do that, you can see that you got a series. So here you have series. Remember, a data frame is multiple series that share the same index. Selecting multiple columns. So far we are talking about selecting only one column and selecting a column. And now we want to talk about selecting multiple columns. So the best way is this. The best trick is name of the data frame, whatever it is, then inside brackets, list of columns. So because list of columns had it's like another bracket, you're going to have 2 brackets. So something like this. df bracket a and c. So this one is the list that we are looking. So you do that, you get a subset of data frame that only includes column A and only column C. Now if you check the type of this, it's not going to be series, it's going to be a data frame because you have more than one column. You can do that again for example, dfa. Now here you get a data frame, not series. Yeah, you check that type, you'll see that's a data frame. So you might ask, what's the difference between these two? So between this and this one, sorry. So here for df, we only had one bracket. I didn't pass a list of columns. Here I passed a list of columns. The list included only one item, but it has 2 brackets, so it gives you a data frame. Creating a new column. If you want to create a new column, you can say df new equals df, for example, a plus dfc. That's going to create a new column. Dropping a column is easy as well. df.drop, then the name of the data set that you want. But let's see if that works or not. If you do that, you get a key error. The key error, bracket.new not found in access. What's going on? We'll get key error key noon and not found in access, because we can use dot drop to drop both rows and columns. So this dot drop is for dropping both rows and columns. The default is removing rows. In Python, axis 0 indicates rows and axis equals 1 indicates columns. So if you want to drop a column, you have to say df.drop new then axis 1. It means we are dropping one column, not one row. Then it works. However, yet data frame df has not changed, because when you do this, you're doing that temporarily. If you want to make it permanent, as always, you have two options. Two methods to permanently remove this column df. Either this one, to just say df equals df drop new axis 1. So whatever I had before, but df equals that. Then the change is permanent. Or let me reverse that change. Or I can just use in place equals true. With that also works. So that was removing a column. If you want to remove a row or multiple rows, this is the way you can do that. df dot drop g axis 1. Axis equals 0. So now you removed row G. However, if you run this dataset again, you can see that the change is not permanent. As always, you have two ways to make the change permanent. Either say df equals then whatever you have, or say in place equals true. So let's get back row G back for a second method. So here I'm getting dataset again, and then df dot drop g axis 1's in place equals true. That makes the change permanent. Now the change is permanent. Now axis equals 0 is the default. We don't have to even mention it. Default for in place is false. So it's a good idea to know default values. So default for in place is false. Default for axis equals 0. To check the defaults, type df4.drop and press tab. It just gives you the defaults. For example, df.drop and then tab. Gives you this information box. Okay. Now df.drop f, you can see that we didn't mention axis equals 0, and we still temporarily we got rid of row f. Take a look at df again. You can see f is back because the change wasn't permanent. Also, always be aware that Python is case sensitive. So df drop axis 0, this one gives you an error because capital letter B was a column, was not a row, and here you're saying axis equals 0. You do this df drop then B axis 0, that works. Now row B is gone. So Python is always case sensitive. That's very important to remember. So now we want to select, for example, selecting rows, and we want to focus on two ways that we are going to use both of them. For that, let's take a look at dataset df, data frame df. One more time. Data frame df has rows A, B, C, D, E, F. and it has columns ABC, and so we got rid of the row G, which doesn't matter. Like we can add that up or not, whatever. Just for the sake of it, let's get back to the original data frame DF so we know what we are talking about. So now it has all the rows. Okay, now we want to select, for example, row A, the first row. One way is df.lock, which stands for location, df.lock, and then in brackets we pass in the name of the index. And the answer is this ABC, so 3 columns. So it gives us the results in terms of series. Yeah. For selecting more than one row, pass in a list of locations. For example, you want both rows A and D. You do this df.lock brackets and then pass in a list of rows that you want. So for list, you need another bracket. So you're going to have 2 brackets. And you run this. Now you get a data frame. The answer is not a series anymore. So it's a data frame. You got the A and rows A and D and all columns. So that's one way. Another way to use iLock. Yeah. This one is you pass in numbers. So for example, if you want the first row, you will say df.ilock in bracket 0. And then if you want rows A and D, you pass their positions, so 0 and 3, like indices, index location, ilock, index location. df.ilock is you have one bracket, and then inside that you pass in the list of rows that you want, which is an index 0 and index 3. So you're going to have 2 brackets, and then the result is going to be in terms of a data frame. Now, subsetting rows and columns at the same time. So we have many different ways to do that. But let's say we are going to talk about 6 ways to select rows A and D. So we want these 2 rows, and we want columns A and C, capital letter A and capital letter C. Okay, let's have dataset DF. This is dataset DF, and now I want rows A and D. So I do this df.log A and D. If I run only this, I get all the columns, and then off of this I can say like bracket and then pass in the list of columns that I want. So it's going to be bracket A and C, and with that I'm going to get this, which is obviously a data frame. Or you can have ilock and then pass in the position of rows and then the name of columns. Or you can say df A and C. So here with that you're selecting columns A and C, and then off of that you can say dot log A and D. Or you can say df A and C, then ilock 3 and Z, because this is a data set. Yeah, this is a data set. Off of that you can ask you can have either lock or ilock. So these are nothing new. Yeah, this is a data set. Then you get you can get like a 0 and 3 rows indices 0 and 3 off of that. Just one more thing that I am sure by now you know, but just to remind you, if I select a part of a row, a part of a piece of code, and I select F9, then only that highlighted part would be executed. If I don't select any part of a row, then if I press F9, the whole like code in that line will be executed. And then another way is to just say df lock A and D in. So here I have all of them in like brackets A and D and then A and C, or I can use that ilock and then I can say this. So ilock is index location. So if you don't want to use the name of rows and columns, you can use ilock, or you can use a combination of lock or ilock. 6 ways to select elements in the second row and third column. So let's take a look at df one more time. We haven't changed df, so it should be the same as before. This is df. Now I want element in second row and third column. So that's going to be this. Yeah, negative 0.34. So that's one way mentioning the name of. So this is going to be a series, and off of that I can use .lock or .ilock, or I can just do this. Like all of them give you the same results. df.ilock, then inside brackets 1 and 2. That also works. Okay. With that being said, we'll move to next topic, which is conditional selecting. Conditional selecting is different than selecting just based on location or index location. Let's have that dataset df one more time. This is dataset df. Now, off of this, I want to say, for example, df greater than 0. If I do that, I get a matrix of booleans. So either true or false. I'm going to have true if the element that we have is greater than 0, if that condition is satisfied. So I get a matrix of boolean. And then if I pass that matrix of booleans into df, then I'm going to get this. I'm going to get a matrix which has like elements as before, only for when we have true. For all other, when we have false, I'm going to get missing values. I can pass that to, for example, df2, and then df2 would be this. Okay, or I can say output a subset of df4, for example, just df, where b is positive. So I put the condition inside. I say df, and then inside brackets, I'm going to have df, like column B is positive. And out of that, I can see this. So I'm going to get all rows. I'm not going to get any missing values, but I'm going to get only rows that elements for B is positive. So I got rid of element rows C and D and F. Yeah, and then indices that we have are based on old indices that we have. So question, without running this code, let's guess, what does the following refer to? What's the output? So it says df b positive. So it's going to be something out of this. And then it says A and C. So we are going to have only columns A and C. And then location, ilock A and B. Location A and B. So it's going to be first 2 rows. Yeah. 2 rows and then column A, column C. For multiple conditioning, use and or. This represent and this guy is the vertical line is represents or. Okay, so for example, I want only that those elements, those rows that B is positive and C is, let's say, less than 1, or let's say less than um, 0.1. Yeah, if I run this, I get this. So now I don't have row E. Why not? Because row E does not satisfy the second condition. You know, when you have and, so you know, I'm sure you know this, but true and true is true. True and false is false. False and true is false. True or false is true. You know these Boolean operations, yes? So make sure that you are familiar with this, but just to remind you guys, I'm gonna just write them down. True and false is false. Combination of these two is false. False and true is false, and of course false and false is false. Yeah, that's for and if you want to use or true is true, and then true or false. Now if one of them is true, then or is going to be true. If you have false or true, oops, if you have false or true, then that's true. And then if you have false or false, then that's false. Okay, now for example, if I want df, either b is greater than 0, or for example c is less than 1. So if I do that, I'll see like I got everything, yes, not d, but all other rows. So I got a because b is positive. I got row b because again b is positive. I got row C because C is less than 1. I didn't get row D. Why not? Because none of these conditions were satisfied. So F was negative and C was greater than 1. And then I still got like rows E and F and G. E and G because B was positive, and C because and row F because C was less than 1. So this is also very important. Okay, next, let's move on to the next topic that we have: set index and reset index. Let's say we have dataset df4, and let's take a look at that dataset. So it consists of 4 variables and 4 rows. And if you want to convert a column to index, now, for example, I want column name to be my index column. I use this df4 dot set underscore index name. And as you can guess, So now I have name column as index column, but as you can guess, the change is temporary because we didn't make it permanent. To make it permanent, again, as always, I have two ways to do that. Either say in place equals true, then the change is permanent. If you want to convert the index to a column, you can say df.reset underscore index, but still df4 is not changed. Still column name is index. If you want to make the change permanent, as always, just say in place equals true, and then again that column is back. That index column now is a column itself, and indices are automatically generated 0 to 3. Another example, let's say math as a matrix of, so whenever I have this math would be resetted. Okay, now I'm gonna have math, and then I'm gonna have df and all the names. So make the index a column and make it a permanent. So here I have I want to make the index, which is A, B, C, D, E, F, G, a column and make it permanent. I do this, df equals, so that's the second way to make them permanent, and then you run that, you see that you have this index column. Now this is a column with name index, and now it's a column. Okay, now let's get back to original df. To make a column, any column index, we can do this df, for example, new, which is HIJKLMN split. I'm like creating a column. So here I have a ABC, and then I have a new column. Then I want to make this column new my index. I'm gonna, for that, to set a column as index, all you have to do is to say df.set underscore index. So just remember, whenever you want to set a column as index, just say df.set underscore index. If you want to release it, just say df.reset underscore index. So to release the index column, say reset. To set a column as index, just say df.set, which makes sense, yes? So I will do this, and then my new column new is going to be my index. Note that we lost the original index. Original index was A, B, C, D, E, F. A, B, C, D, E, F, G. So we lost that. If we don't want to lose it, first reset it. How? Let's see. So I'm going to have df, and these are a list of columns that we have, A, B, C, D. I'm going to take it, before everything, I'm going to take a look at df. This is df. These are columns that we have. These are indices that we have. And then I'm going to say df.reset index in place. So in this case, I'm going to release my index column, and in place is true. So now I released my index column and now I have index A, B, C, D, E, F, G. And now I'm going to add this new column, new, and then take a look at df. So I should have taken a look at df before setting that as index. So let me just do this again really quickly. This is my data set df. This is the name of my columns. And you know that you can always have them as a list, yeah? All you have to do is to say list and then df columns. Then that gives you all the columns as a list. or df index, and you can have that again as list if you are interested to having that as a list. Just pass in it in a list keyword, and then you're going to have all the indices as list. Okay, now that I have that, I'm resetting the index column. Take a look at this. Now I'm creating a new column called new, HIJKLMN. If I take a look at this df, you can see that I have the df has now this column. It had column index, now it has column new, and then I want to have column new as my index. So all I have to say is df dot set underscore index new, and in place equals true, and then I have this. So now I preserved my index, my old index, and I set my my favorite column, which was new, as my index column. Okay, great, awesome. Let's move to the next topic. 4 important ways to get to know a data frame. Let's say you have a very simple data frame, 2 columns, 3 rows. Columns A and B, rows index 1, 0, index 1, index 2. If you want to, so these are 4 different things that you want to know. For example, df head. Okay, you can have that df head. It shows, right now it shows like all the rows, but if you had more items, then that would be a great example. Let's say here we have, let's say 20, and then 21, and then 22, and then 23, and then here I had, for example, 6, and then 7, then 8, then 9. Yeah, so I have, and then 10. So now let's run df. So now if I run head, you can see with head you only see like first 5 columns, okay, first 5 rows. That's something interesting. df head, let's say you have a data set with thousands or millions of rows. You want to take a look at only, let's say, 5 rows. You use this df dot head and then parentheses. So one more time, this is data set df. With head, you can get hold of first 5 rows. Now you can also have, for example, df.head if you want, for example, only first, I don't know, 2 rows or like 6 rows. You can mention any number that you want here. It gives you only first 2 rows. We also have df that you can also use df tail. Df tail also gives you you can have, for example, df tail. This one gives you last 5 rows, yeah. Or you can have, for example, again df.tail, let's say 3. It gives you last 3 rows. That's a very cool thing, yeah. And another thing you can use, other things you can use is df describe. It describes your data set. Count, mean, standard deviation, minimum, 25 percentile, 50 percentile, which is median, 75%, and then maximum. And now this only works for data sets with columns with numerical formats. Imagine you have a data set df2, okay? df2, let's take a look at that. It has 3 columns, A and B, exactly like before. Column C has a letter, okay? So we know that It doesn't have minimum, maximum. If you say df2 describe, now it gives you this mathematical summary only for columns A and B. Another good thing is df type, or the name of dataset d types. That's also really good. It gives you, for example, column A is integer, column 2 is integer, column C is object. And the info, for example, df2 info, it gives you some information about them. It tells you df2.info class pandas.core.frame.dataframe, so you know you're dealing with a data frame, 7 entries, range index. So you know your indices are from 0 to 6. Total data columns, total 3 columns. Columns that you have here is their column. The first column is, or column index 0 is A, column index 1 is B, column index 2 is C, and then you have 7 non-null data there, and then the type is also given there. So, and D types, there are 2 integers and then 1 object, so that gives you very good information. Also, you can have df, either df or the name of data set and then dot shape. It gives you 7 and 3, so you have 7 rows and then 7 rows and 3 columns. If you want the number of rows, one way to do that is this: df, the name of data set, for example, df2 dot shape, and then in brackets 0. That gives you 7, and then df2 dot shape in brackets 1. That gives you number of columns. Yeah. So we also can consider again df dot head 6. It gives us the first 6 rows, and then df tails, last 3 rows. Okay, that's one thing. Other things that we want to learn is, for example, value counts. Let's say we have conditional selection. SER is like when B is greater than 0. So if I take a look at that, it's all true. Let me say something that is not true for all columns. So for example, df is, this one is greater than, let's say, 5. Okay, SER is this. So for the first 2 ones is false because they're 4 and 5, and 4 and 5 are not greater than true. So these value counts gives you how many true you have, or how many true and how many false. So you have 5 trues and you have 2 falses. So, and then you can sum them, you get 5, because true has value of 1, false has value of 0. Yeah, so you add 1 5 times, you get 5. Or you can see the length of that, length of this series. So you get 7. Okay, so far so good. And then we are going to move on to the next subject, which is group by. So let's talk about group by. We use group by to when we want to group together values of a column based on another column. So we have two columns. We want to group by one column based on another one. Pandas will automatically make the group by column the index of the new resulting data frame. Let's see what's going on. So just imagine we have a data set like this. And let's take a look at that df. We have 7 rows, yes, from 0 to 6. And then these are different people. We have gender M, male, and gender F for female. And then we have height of these different people. Now, We want to use group by. So the format is, generally speaking, is the name of data frame, so df dot group by, and then inside parentheses the name of the column that you want to group by with respect to that. Okay, so something like this. But if you do that, you're not going to get any results. Why not? Because you need to perform some sort of like aggregate method. What does it mean? Something like mean, max, median, count, sum, standard deviation, describe, something like this. You need to have it there. And let's just have mean. Now here we can easily calculate the average heights of females and average height of males. Yeah. Interpretation: the average height of men in our data frame is 7.5, and for women is 61.3. So another example, group by max. We can see the maximum height in each group. For female, 63. For male, 75. And then again, in both examples, look at here. Gender is here. It's not all the way up here. Gender is here. Gender is index. So in both examples, you can see that gender has become the index. So group by operation makes the column that we grouped by it the index. Okay. Another example, count. Let's see. We can see that we have 3 female, 4 male. Another one, let's see, sum of heights for women and for men. Another one, standard deviation. You can see that. Describe. You have that. It's you can also just do this to make this a little bit bigger. You can see like the height count, mean, standard deviation, minimum 25%, 50%, 75% percentiles, and maximum. Or if this is hard to see, because some of it is moved to the next line, you can always do this. Get it like, let's say, add dot transpose, and then you're going to have it like this. You're going to have female and male, and then each of these values, count, mean, standard deviation, right there. So that's group by. Let's move on to common operations that we have. A couple of them that I want to talk about. The most important one is value count. So let's take a look at dataset df one more time. It's just the thing we created. And then we have df gender. So we are focusing on gender column, so df in brackets gender gives us series, and then dot value counts. It gives you how many male you have, how many female, and then you can also say unique. So it shows all the unique values that you have, just 2, M, and F, and then n unique gives you how many unique values you have. Or you can use the unique and inside length. This is equal to n unique. Okay, that's it about common operations. Let's talk about dot apply that we have. Dot apply allow the users to pass a function and apply it on every single value of series or data frame. It's very important. We are going to use this all the time. Now for this, we are going to have an example. df1 is a data set for data set of 4 people, Kia, Jamie, Surush, Arash, and we have their heights. Yeah. Now we want to do this. So let's say that we have name. We are creating a new column. Yes. The column is name length. This column tells us what's the length of each name. So for Kia, it's going to be 3. For Jamie, it's going to be 5. For Surush, it's going to be 7. For Arash, it's going to be 5. And so we can do that by dot apply function. Here we use like predefined function that we have in Python. We can have a little bit more complicated example. Let's say that you want to create a third column or fourth column, let's say, but it's based on or conditioned on another column. It's based on their height. Now, the function is called DES maybe. It's just a name. We say if number is less than 64, return short. If number is between 63 and less than 70, return normal, else return tall. So we define this function DES, we run this code, and then we say df1 status. So we are creating a new column. It's df1 height dot apply this. You do that and you take a look at df1. You see that status is like short for Kia. Why? Because height is less than 64. For Jamie, it's normal. For Surush 74, it's tall. For Arash 70, for Surush 74 tall. We said if it is more than 70, then it's gonna be tall. For Arash, it's gonna be tall as well. So here we are creating column status based on another column, based on column height. So that's very important. If you want to create a column based on another column, you use dot apply. You define a function, then you create, you use dot apply, and then you do that. Okay. And you see that in place is true automatically. A bit more complicated. Remember this from chapter 1 exercise. Chapter 1, write a function which has 2 inputs, gender and height, and return one of the 3 possible results, short, average, or tall. For males, height below 65 is short, between 65 and 72 inclusive is average, above 72 is tall. For female, height below 60 is short, between 60 to 65, 67 is inclusive is average, above 67 tall. Call the function classify. What are the outputs for classify f and 62, m and 62, and f and 70? Now, here, so it's a more complicated function because it has 2 inputs. One input is gender, another one is height. Now we define this. How do we do this? We first say that if gender is f, height equals height plus 5. If gender is m, just forget about that. And then these are based on what we have for male. Yes, for male we said less than 65 short, between 65 and 72 average, and then above that average or normal, and then above that is tall. Yeah, so we define this function and then we say classify this, like so if you give input f and 62, you get average, m and 62 you get short, f and 70 would be tall. Yeah, so notify that classify function and apply on df to create new column status. So now we have this data set of 7 individuals, And now we want to, based on their gender and height, create this new column status. So here we are defining this function, very similar to before. df classify, the argument is calls, but calls is a list. It has two inputs, calls 0 and calls 1. So gen and gen and hea. I didn't use like the entire word gender or height because I didn't want to get confused with what we have gender and height as the name of variables. But gender is the first element of list, calls list, and height HEI is the second element. And again, let me say if gen is F, then HEI equals HEI plus 5. And then the rest is as before. So we do this. And then I do this. df status equals df. And then I pass the list of a list of variables that we have, then dot apply, then the name of function that we have, classify underscore df, that was the name of function, and then you have to mention axis. So here is we are creating a new column, so it's going to be axis 1. So you do that, and then you see that you have a new column called status. So here we are creating a column, it's called status, and it's based on two other columns. This is a very interesting example. Make sure you know what's going on here. Okay, next topic, permanently deleting a column. So if you want to, for example, delete a column, let's say you have a data set df, and here's our data set. Method 1 drop in place equals true. So here I can say df dot drop height axis equals 1 in place equals true. I do that, you see this is the remaining of that df. Method 2 is the same thing, drop, but here we say df equals df drop. So it's the same method, the same result as well. Method number 3, we use del. So as a matter of fact, it's method 1 and method 2 are the same thing. They're both just drop. So, but this is method 2 using del. So let's get back to the original df that we had. Let's take a look at that, and then we say del, df height, and df. As you can see, it's permanently already in effect. Getting name of columns and indices. So you have, for example, you have a data set, and let's take a look at that. With df columns, you can get all the column names. With df index, you get all the indices. If you want, in many cases, you want to have them as a list, so you can use them later on. You can say list df.columns, that gives you a list of all the columns that you have in your data set, and list df.index gives the list of all indices that we have. And you can also use df.info, and you can use df.describe to see what's going on. Okay, sort a data frame. So in many cases, we want to sort a data frame. How do we do that? Very easily, with df.sort. So here we have this data set. Let's take a look at df first. I have this, and then I want to sort it with respect to height. So I can do that, but is it permanent? As you can guess, no. If you want to make it permanent, you need in place equals true. And then as ascending can be true or false. If it is false, it goes from the highest number to lowest number. So with dot sort underscore values, you can sort your data set. Okay, next very important topic is reading and writing files. That's super important. Okay, let's talk about reading and writing files. Okay, let's say we have a data frame similar to this. And let's take a look at this data frame. So it has 4 variables and 4 rows. And then I want to, for example, write this data frame as a CSV file. So CSV stands for comma separated and then you want to write that as a CSV file. It's very easy. All you have to do is to just say the name of data the name of data frame, and then after that dot to underscore CSV, and inside parentheses, and of course inside quotation mark, you're gonna have the path to that location that you want to save. So one more time, you have a data set, you want to write it as CSV, commas, separated values. It's like a format of most typical format that we have. So name of data set, in this case df, then dot to underscore CSV, then inside parentheses the path. So here I'm gonna save it in this path. It's gonna be different for you. So here obviously you gotta change this. Yes, you gotta change this to whatever is your desire. But when I do that, I'm just closing off my other files because I wanna. So here, let me show you one more time. So at the beginning, we don't have this CF file. Now I run this code. The name of file is going to be CF. It's just an arbitrary name I'm assigning to this. So I run this code, and then when you check this, then you're going to have this cf.csv here. If you open that, you can see that you have this data set. So you have name, height, age field. You also have another column without any names, which shows indices 0, 1, 2, 3. So that also appears here automatically. That's added. So Python adds that Pandas adds the column for as index. So if you open this CF file, you see a new unnamed column with values 0, 1, 2, 3. To avoid having the index column as the first column, we can do this. So all you have to do is run this code, something like before, but after the file, after determining the path you're going to have comma and then index equals false. So here I'm saving the same data frame as CF2. Okay, when I do that, CF2, you see now I have another one, CF2, and you open that. As you can see, there is no initial column that we had before. Good. So that's how we can save our files. Now, if we want to read a file, for example, now the same CF2, that's a file, yeah? You want to read this file. How can you read this file or any other files, any other CSV file? How do we do that? To read a file, we do this. We use pd.read underscore CSV and then path to the file. So here, before, this was the path we wanted to save our file, and this is the path of the file that we want to read it. So I'm calling this dataset df2, and if I read it, obviously it's gonna be something like this: name, height, age field. As you can see, Pandas automatically generate index. How we want to manually set the index. So you can start from here and then change it. But if you really want to manually set the index at the very beginning, we create a dataset called df3. So you set, again, exactly as before, pd.read underscore csv, and then inside parentheses the path to the file, and then after that comma, and then index underscore call whatever column that you want. So here, first column, so it's going to be which has index 0. And if I open df3, you can see now names are as our index. Okay. Now, if I convert df3 to a CSV file, I want to see what happens. So df3 has an index which is names. Yes, I want to convert that to a file. So I do that easily. I run this code. And then I take a look at df3 here. Let's take a look at that. Now, as you can see, first the index column is now the first column. So we didn't have to, if you want to preserve the index, you don't have to say index equals false. If you want to get rid of the index, you can say index equals false. That was the very first type of dataset that we wanted to work with, and it's most common, CSV. The second one is Excel files. Okay, now let's have the same from df. Now I want to write df as an Excel file. For that, it's very similar, but rather than to CSV, we are going to have to underscore Excel, and then inside parentheses the path to the file that you want to save. But here you have to say also, for example, sheet underscore name equals whatever sheet name you want to have. And so now if I take a look at this data set, if I first run this, so here I'm running this, and then if I take a look at this data set, so you can see I have cf.xlsx. You can see that I have name, height, age field, everything as before. But since Excel can have like different sheets, here we have S1. The name of this sheet was determined in our Python code. Name sheet underscore name was S1, and then index was false. Yeah. So we didn't save the index. Okay. Now let's see how we can read Excel files. Now we have an index file. We have an index file, Excel file. This is our Excel file. We want to read this Excel file. How can we do that? Again, very easily, super easy. Just pd.read underscore Excel and then path to the Excel file and then sheet comma sheet underscore name equals the sheet that you want to be read. So S1. So if we do that, take a look at that, we see that we have this df4. Yeah, very easy. Now, having that in mind, we want to, for example, read a Excel file, but here we want the first column to be our index. So while reading the Excel file, I want to assign the first column or name column as my index column. All I have to do is to say index underscore col equals 0. Then my column 0 is going to be index. And if I want to convert that to Excel file, this df file, all I have to say, as before, df5 to underscore Excel, and then this, and then sheet name S1. So that's going to be CF2. Here we go. I'm opening that. And as you can see, you have name, height, age field. Okay. Third format that we want to work is HTML. Let's say we have a web page. For example, this guy. And I want to get the data sets that we have here. Yes, we have this data set in this page, and I want to get that data set. How can I do that? So for that, we say data equals then pd.read underscore HTML. So that's new, yeah? And then the name of website or web page that you want to be read. So I do that. And then as I can see, the type of our data is list. This list, I can check the length of this list. Six. And then I can, for example, say Apple equals data 1, and then take a look at Apple. Is this one. is this table that we have. So just remember, elements of a list can be data frames. That's very important. So data is a list, as we saw, and then it has 6 components. Apple is going to be the second component, or component index 1. Then take a look at Apple. Type of this Apple, if we take a look, this is a data frame. So, and this data frame has 2 columns, yes. Column number 1 is called Apple quarterly gross profit in millions of US dollars. Second one, Apple gross profit in millions of US dollars. This second one is the quarters, okay? So this is the index number. The first column is quarter. The second column is Apple quarterly gross profit. Okay, with that having in mind, we can have like aapl.columns and set the column names to quarter and profit. Let's take a look at Apple one more time. So as you can see, it's something like this. Quarter profits, we have 2 columns, we have 66 rows. And you can easily convert that to a CSV data file. You do that, and then you can take a look at the CSV data set itself. And here we go. We have 2 quarters and profits. Now, and also just note that we set index equals false. So these 5 lines, don't worry about them that much. I'm going to just quickly talk about them, but it doesn't matter. I want to just show you how we can do many different stuff in Python. First, Apple quarter, I'm converting this Apple quarter column to date time, and then I'm gonna get a date format out of it. And then here I'm sorting values by quarter, and then here I'm getting rid of replacing this dollar sign with nothing, so getting rid of dollar sign as a matter of fact, and then I'm gonna have the profit as float. So what we are doing is that I'm going to just run everything like really quickly again. Replace the name, dataset AAPL, converted. Then here on the first row, I'm converting quarter to datetime object. And then on the second one, I'm sorting values by with respect to quarter from first quarter. So if you take a look at AAPL before this, you can see that it starts from 2021 and goes down. I want the other way around, so I sort. And now if you take a look at AAPL, you can see that it starts from 2005. So that one is different. Now it's sorted. Now I have this expression that I'm replacing the dollar sign with nothing. As a matter of fact, I'm getting rid of dollar sign, and then This is like sum regex means regular expression. That should be true there. And then as type float, because I want to have my profit as float, not as a string. I do that, and then I can just visualize this. So this is the profit of quarterly profit of Apple from 2005 to 2021, and you can see how in time it has changed. It has gone up, and how exactly it changed. So you can do this like great stuff in Python. Okay, let's move on to the next very important topic. It's about missing data. Okay, let's talk about missing data. There are different ways to deal with missing data. For example, you can delete the entire column, you can delete the entire row, or you can replace the missing data with another value. So for that, just assume that we have this dataset df, and now let's take a look at this df. So we have three columns, A and B and C, and column B includes one missing data. We have 5 rows, 5 observations or rows, and then column B has 1 missing data, column A has 0, column C has 2 missing data. Now, first of all, we want to check if we have a missing data or not. One thing that we can do is that say df name of dataset and then dot is null and then parentheses. If you do that, you get a data frame like this, consists of booleans. It's false if you do not have a missing data. It's true if you do have a missing data. What we have here is a little bit hard to read. We can use the following. It helps us a little bit better. In each column, it shows how many missing data we have. So for A, we have 0 missing data. For B, we have 1. For C, we have 2. Another thing that we can do is that have df.isNull.sum.sum. So it adds all of these numbers together, so we'll get 3. We don't have any missing data if this number is 0. Okay, now that we discovered if we have a missing data, missing value or not, and now let's talk about the methods to deal with missing data. So number 1, delete all rows with missing values. So something like this, df.drop na, and then inside parentheses x is 0. So it means we are going to delete the row, and take a look at df. So as you can see again, the change is not permanent. Here, as we just saw, when you do that, the change is temporary. Make it permanent either with in place equals true, or reassign it df equals df.dropNA axis 0. Method 2, delete all columns with missing values. We can also do that. Let's see how it works. So here, column B has a missing value, column C has a missing value. So we are going to have only column A. This is less common. Method 1 is way more common, to just delete all rows with missing data. But deleting all columns with missing data is usually less common. Number 3 is also very often used. So either method 1 or method 3 is used usually. Fill them with something. So it can be, for example, the word fill, fill. So the way it works, you'll say df, which is the name of your data set, dot fill na, then inside parentheses value equals then what you want to be to replace the missing value. Another example, you replace missing value with 0, and then df hasn't changed, so as always you can make that change permanent with in place equals true, or reassign what you have to df. Another way is that replace all missing values with 0 and all other values with 1. However, usually we do this column by column, but that's also one way that you can do that. For example, here for column C, we did it. If we have missing value, it's replaced by 0. If it's not a missing value, we have it 1. So it's np dot where, and then df's column C is null, then it's going to be 0, and if it is not null, it's going to be 1. Above does not make much sense. Why not? Because you're getting rid of valuable information. You're replacing all the non-missing values with only 1, which is just wasting resources. How about we fill them with mean of the column values? So let's take a look at df one more time. Okay, now df has been changed because we assigned this df, this column C. So we have to create this df again. Let's create this df again. And now, so df.fillNA values equals df mean in place equals true. So now we replace them with df mean. How does it work? In this method, when you're doing this, Python goes and calculate mean of each column before replacing the missing value. So for example, for column B, we have 8 and then 10, 18 plus 12, 26 plus 16, 34, 44. Divide, if I'm not mistaken, one more time, 8 plus 10, 18 plus, 18 plus 12, 30 plus 16, 46. Divide 46 by 4, you get 11.5. So column B, all the missing values that we have, which is only the third component, is replaced with mean of that column, which is 11.5. Column C, you have 0, -1, -2, so add them up, -3 divided by 3, -1. So mean is -1, then both missing values are replaced by -1. So that's one way. Or you can do it for each column separately. If you want, you can do that as well. Since we had in place equals true, I'm resetting the dataset df, and then you can do it for column B and then for column C separately. You can do it once for all columns or just do it column by column. Another method which is more common, we use median more rather than mean. Let's take a look at this. df again, and then you can do it column by column. So median here is 11 for column B, and for column C, median is -1. So we replace that missing values with the median of each column. Or you can do it once for all columns. So don't do it like separately. So just df.fieldArray value equals df.mean, comma, in place equals true. Another method. So here in this method, we are gonna say df.drop_na axis equals 1, thresh equals 2, in place equals true. What does it mean? Thresh equals I keeps each row with at least I non-na values. So we don't delete all rows, we just delete, for example, we'll keep rows with like at least 2 non-missing values. So here, you take a look at this, you see that, for example, row index 2 has 2 missing values, only 1 non-missing value. So that would be deleted if I run this. But row index 4, it has only 1, it has 2 non-missing values. So you do that, and you see that column row 2 is deleted now, row index 2. And then you can fill NA later on by another method. Yeah. Okay. One more smart points that one more smart way to do this, and then we are done. Filling missing values with respect to another column. So for this, I have a very good example, a funny example. I have a data set here, consists of 2 columns, gender and number. And then I have 7 observations from index 0 to index 6. Here, gender is gender. Number is number of, for example, penises that they have. So it's going to be either 1 for male and 0 for female, yes? Now, if you do this and you have this missing values, for example, if you use fill NA with median, you get something like this. So since median is 1, then for male you get 1, but also for female, row index 6, you get 1, because median is 1. So here you're assigning 1 to F. Or another thing, if you fill NA with mean, then what happens? Then for row index 2, you get 0.6, and for row index 6, you get 0.6. Which is even worse. It doesn't mean like 0.6. It's going to be either 1 or 0. No one has like 0.6 penis. Okay, so it's even worse. Now let's take a look at df one more time. We have 2 missing values. Now we can manually resolve the issue like this. For example, we can replace the first missing data with 1. So just say df in brackets num.ilog2 equals 1, and then .ilog6 equals 0, and then take a look at df. So we did it, but it doesn't make that much sense. If you have a big data set with 1 million observations, you don't want to do this manually. Yeah. But what if there are thousands of missing values? It's going to be time consuming. For that, we can use different ways. For example, one of the ways that we can do this is by using group by. So let's see how we can achieve the same thing by group by. So first, we are gonna define something called df, and df is gonna be I'm sorry, temp. Temp is gonna be something like df group by dot median, and then out of that we are gonna get just num. So if we do this, only df group by gender median, then we have that, and then if we get this, it's gonna be get only the just the number. So, and it's gonna have like two components. It's gonna have 0 and component index 0 and index 1. So we can see temp. Oops. This is temp. Okay. Now, having that defined, we can define a function. So define function impute. The input for that is calls. Calls is a list. It has two items. Number index 0 is gen, index 1 is number. So I intentionally didn't call them gender and num because I want them to be different than the names that we have here, gender and num. Okay. Gen calls items index 0, number is calls item index 1, and I say if pd dot is null number. So if this is true, then return. So if we have a missing value, then return temp dot loc location in brackets gen. Else return number. If it is not missing value, then return number. So, okay, if we define that, I encourage you to just go through this one more time and make sure you understand this function. After defining that, we can just say df num. So right now df is defined as, let me have df one more time. Let me define df one more time here to make sure everything is fine. So this is df, and having this defined, I'm gonna show you how easily with this function automatically we are gonna have 1 for male and 0 for female. Okay. That's a very good example. Let's move to the next topic, which is about categorical variables. Many forecasting and prediction techniques cannot work with numerical procedures. Therefore, we don't want to lose our precious data. We have to convert categorical variables to numerical. In this part, we focus on this. So the problem is that we have a categorical variable, and then we want to convert that categorical variable to a numerical variable. That's very important. Okay, let's see. Consider a data set like this. Dict1, it's a dictionary. And then out of that dictionary, I'm going to make a data set. Let's take a look at this data set. It has 7 observations, and 1, 2, 3, 4, 5 variables. Now, with value counts, I can see how much each category has. Value count is usually very good for categorical variables. You can see how many observations you have for each value. So for example, here for gender, we have 4 male, 3 female. For eye color, we have 3 brown, 2 green, 2 blue. For number of siblings, we have 2 people with 0 siblings, 2 with 1, 2 with 2, 1 with 5 siblings. Number of kids, 3 with 2, 2 with 3, 1 with 0, 1 person with 1 kid. Okay, method 1. Convert one column with customized values when you only have 2 characters. If you only have, for example, 2 characters, 2 categories like female and male, you can easily do this. For example, df gender is np dot, you use dot where, np dot where df gender equals f. So if gender equals f, then it's going to take value 0, otherwise it's going to take value 1. You do that, you easily get that f and m replaced by 0 and 1. When you have more than 2 variables, with some of them potentially more than 2 categories, then that's going to be a problem, and we have to use other methods. So let's refresh dataset df and take a look at that, and let's look up for some other ways. The best way, this is my favorite way, to just define a dictionary. You can name this dictionary whatever you want. Here, for example, I called it cleanup cats, and then let's run this, and then so this is a dictionary. Yes, this is a dictionary, and then we're gonna use df dot replace and then cleanup cats and in place equals true, and then take a look at df. You can see that all the categorical variables are replaced with numerical variables. Let's see what's going on. The secret is in this dictionary. So in dictionary, each key is name of variable, gender, name of a categorical variable that we want to do the change. So it's gender, and then eye color, and then number of siblings, and then number of kids. So these are all for so look at this: gender, eye color, number of siblings, number of kids, and then we have these 4. So for that, we define a dictionary with 4 keys, and then each key for each key we have a value. The value itself is a dictionary. Each value is a dictionary. Inside the second dictionary, we define each categorical variable as a key, and then the colon, and then a numerical that we want. So F0 M1, then for eye color, and definitely everything should be like, all the strings must be like inside quotation marks. Eye color, brown 0, green 1, blue 2, or whatever numbers that you want. Number of siblings, 0, 0, 1, 1, 2, 2, 5, 5. number of kids, 0, 0, so on, so forth. So you define everything, and then just all you have to do is say df replace, and then the name of this dictionary, and then in place equals true. And you're done. This is my favorite method. This is really, really cool. However, there are some other ways to deal with categorical variables as well. Let's see more ways to deal with categorical variables. Method number 2. Let's refresh dataset df and then check method number 2. We see list here. All I'm doing here is I'm listing categorical variables. I'm listing those variables that they are object. So I'm going to say list, and then inside list, df.select underscore d types in parentheses include equals object dot columns. Yeah. So I'm going to get a list of all variables that they must be converted to numericals. So I get these cat features, so I can just copy and paste this from here. From out here, I can copy and paste it here. Cat features, or categorical features, are these 4 variables. Then for each of them, I say, for example, df gender as type, then inside category, then cat codes. And then for category as well, and then for category, number of siblings, and then number of kids. Yeah, so I'll do that for everything. Take a look at df, and you can see this. So we use keyword cat codes. However, there is a problem with this. What's the problem? Let's look at what was original df and what's converted df. So here, this is original, and then this is converted. So you can see that you have here 0, and then you have here number 3. This is the problem with this method. Sometimes names don't make sense. So here 0 is converted to number 3. Why is that so? Because assigning number is based on alphabetical order. What does it mean? It means that Python goes here inside all of these categorical values that we have. We have 0, 3, 1, 2, and then alphabetically assigns number to them. So 1 is the first, so it's gonna get 0, and then after that comes 3, so 3 is gonna be index 1 or value 1, and then 2, value 2, and then 0, which starts with Z, that's gonna have number 3. So this method is also good, but the only problem is that sometimes they don't make the names don't make sense. But here, if you want to see what is assigned to what, you can use this line. Dict enumerate df number of kids as type category dot cat dot categories. It tells you that, for example, number 0 has been assigned to 1, 1 is assigned to 3, 2 is assigned to 2, and 3 to 0. Okay, so that was number 3. Method number 3, which is also very common, is converting categorical variables to binary variables. It include all the categorical values as a list. Let's see what's going on here, what we are talking about. This is dataset df. Now we use pd.get underscore dummies to create, and then we are going to have something like this. Name of variables, and then columns, and then drop first equals true. So create a fixed larger data frame that has new features, feature columns with dummy variables. Set the data frame as final underscore data. Okay, let's see. So we saw that categorical features are these four. Yes. So I use df equals pd.getDummies inside parentheses name of dataset, columns equals these cat features that we had, and then drop underscore first equals true. And just this one line code does the job. And drop underscore first equals true helps us to avoid multicollinearity. So if I take a look at df, you can see this. So if you have like too many variables, you get this dot dot dot. You can so how can we take a look at all the variables here? If you are interested in that to see all the variables, you can always use transpose, and you can see, so here name of variables are here and observations are here. Since we have very limited observations, it is possible to do that. Or if you want to see it in the original format, go ahead and save it as a CSV. I'm going to save it as a 2 underscore binary CSV. You do that, you'll get the CSV file and to binary. You can see that we have this data set. Yes. Okay, let's get back to this. And that's the third and last method that we are using for categorical variables. Okay, next topic, merging, joining, and concatenating data frames. So let's talk about merging, joining, and concatenating. Okay, let's get started. Let's say we have three data sets, dataset df1, df2, df3. I'm going to just run them. This is df1, df2, and then this is df3. Let's take a look at them. df1 is like this. It has 2 rows, 3 columns, A, B, C. df2 has 2 rows, row index 2 and index 3, and 2 columns, A and B. df3 has 2 columns, D and E, and then 3 rows, rows index 0, 1, 2. Now, we can use pd.concat to concatenate 2 data sets. Let's see what happens when we do that. I'm using axis equals 0. So when you do that, here we had df1, and then so here I have df1, here I have df2. I'm concatenating df1 and df2, axis 0. It stacks data frames on the top of each other. So as you can see, first we have df1 and then we have df2. Use this when you have mostly common variables and different indices. So here between dataset df1 and df2, we have mostly common variables a and b. There is one variable c that is that we have only for dataset df1, but we don't have that for dataset df2. But indices are different, so we use concatenating axis equals 0. What does concatenating df1 and 3 do when we use axis equals 1? You do that. So df1 and df3, they have similar indices, correct? The indices for them, for df1 was 0 and 1, and for df3 was 0, 1, 2. So we have mostly common indices. It stacks data frame on the side of each other. Use this when you have mostly different variables and common indices. Nice. That was about concatenation. The next topic I want to talk about is merge. For that, let's assume that we have two data sets, df1 and df2. Let's take a look at them. We have the indices are automatically generated, 0 and 1, but we have a column called key. So key column has key 0, key 1 for dataset df1, and it has key 0, key 2 for dataset df2. Now, I can do this, pd.merge, and then df1, df2, and then how, we can say, for example, inner, and then on, then the column that we want to use that column to merge. When I do that, we get this one. So when I say how inner is similar to intersection of two sets. Yeah. Inner is similar to intersection of two sets. So between df1 and df2, take a look at the column key. Which one is intersection of these two? Key 0, yes? Sorry, k0. That's what they have in common. So when we are merging these two data sets and we are using inner, that's going to be the only thing that we'll have. Okay, next one is pd.merge df1 df2, but here rather than inner we use outer, and again on key. If I do that, as you can see, we are going to have all keys, key 0, key 1, key 2, and k0, k1, k2. So this is outer is similar to union of two sets. It includes all the keys that we wanted. Sometimes we get missing values, of course, because dataset df1 for like variable, let's say k1, we don't have anything for c and d, but or for variable k2 we don't have anything for a and b, so we are going to get missing values. But okay, next one, pd.merge, everything is the same, but rather than inner or outer we have left. When I do that, let's see what happens. Here I'm getting df, I'm getting all the rows that we have keys in df. So here the left one, df1, sorry, here df1 is the center of attention, but we are going to get all the we are getting all the variables, but here for k1 we get null values for c and d, missing values for c and d. Okay, another one. So left covers keys of the first or left data frame. So left data frame here is df1, yes. when you use left, that's gonna it's gonna take all the on the rows from df1. So left covers keys of the first or left data frame. How about, let's see if we use right. If I do that, it takes so right covers keys of the second or right data frame. So here is the right data frame is D2. When I do that, I get K0 and K2, which are keys in the data set DF2. And of course, I get null value for K2 for A and B. Okay, that's merge. The third thing I want to talk about is join. Join is very similar to merge with this difference. Joining on the index instead of key value column. So here we have index. We don't have so this column that we are using, that's just index. It's not one of our columns. Let's have two data frames. So you can call them left or right, or you can even better just call them df1 and df2 to not be confused later on what is right, what is left, because we are using keyword right and left here as well. So I just use df1, df2. df1, df2. Wherever I have left, I use df1. And then wherever I have right, I use df2. It makes more sense if you do that. If we want to name our data frames df1, df2, it's just easier. Okay. Now, let's take a look at, let's run them. This is df1, f9, df2, f9, and then df1, df2, and then, so we can say, for example, df1 dot join df2, yes, or even better, we use how as well. So again, we have four different methods. We have inner, outer, right, right and left. But before that, let's take a look at df1 and df2. df1 has two variables a and b. df2 has also two variables c and d. The index for df1 is k0, k1, k2. For df2 is k0, k2, k3. So they have k0 and k2 in common. K1 only belongs to df1, K3 only belongs to df2, but we do this, for example, inner. So what are we getting? The common keys, so from both of them. So it's again exactly like this. Inner is similar to intersection of two sets. But here we use it covers indices common between these two data frames. It covers indices common into data frames. And then we can use df1 join df2 outer. This is again like union. So everything is like this one. but the only difference is that we are using our index rather than a column. Very similar. And then this one, so let's have first left and then right. You wanna do, so here we are gonna get keys from our left data set df1, yes, and then you do the right, you're gonna get the indices from the second or right data set. So it's very similar to merge. I'm literally copying and pasting that, but rather than, so left covers rather than keys, I will say indices from first or left data frame, and then right join is very similar to right merge, but it just covers indices of the second or right data frame. So, but again, these are very, the join and merge and join are very common. We use them when we want to, for example, we have two data sets, and then if they have a similar key, we can do that, and we can just simply either uh, make that key our index and then join. But if they have a similar indices, you can just use join. So right covers indices of the first or left data frame. And when I say indices, I mean row indices, yeah, not column for sure. I mean, it's obvious. Okay, that's about joins. Okay, next topic that we have is about multi-column. Let's take a look at this data set. So far, what we have here about DF is this: a data set with 3 variables, 3 observations. Variables are so far automatically, like the names that are assigned to the variables is automatically 0, 1, 2, and to rows also 0, 1, 2. Now I give rows different names. Now let's run this and see what's happening. So I'm giving different names to different columns. I'm using this multi index dot from underscore tuples, and then first first column has the multi index first is A and then B, and then this one is A and C. A is not appeared here, but as you can see here is A and C, and then here this one has D and F. Sometimes, for example, these are, for example, from, let's say, same category, or for any reason the first index is similar between them, and then here the first index is different and also the second index. So we have this. So you can always like say list df.columns, you get list of columns as always. And then here you can also do this df.columns set underscore levels, and then do this. So you can change name of columns in, for example, level 1 rather than level 0, or you can just change the column names, call them A and B and C. Yes. Okay. Let's have an example here, and then we move on to next topic. Yeah. Here we have an extended example. Let's see what's happening. So here we have four lists in this example. We have amount list, we have cost list, we have date list, and then we have category list. And then we are going to make a data frame. We are going to call this data frame DFI. I'm going to it's just a name. And we are going to make a data frame out of a dictionary. So we are going to start with DFI equals pd.dataframe. And then inside parentheses, we have a dictionary. So curly brackets, and then date. Then it's going to be date list. So I could just copy and paste this here, or I just made a date list and I'm saying date equals date list, date colon date list, and then item is this guy split. So it's gonna be car, saxophone, curler, car, slingshot, dove. Yeah, it doesn't matter what we have there. And then dot split, and their customer, it's, let's say, Homer, Lisa, merge Lisa, Bart, Homer. Again, it doesn't matter, just 6 names. And then amount is going to be amount list. Amount list includes 4 numbers and 2 strings. 2 strings are 3 and 4. And then cost is cost list, which is again for 4 numbers and then 2 string, but those 2 strings are numbers. And then category, which is 3 numbers and 3 strings. So with that having in mind, I'm going to run this, and after that I'm going to take a look at DFI. DFI is this, and here you can see amount shows all of them are number, but remember that 3 and 4 here, they are not actually numbers, they're strings. They happen to be a string which is a number. And if I run this DFID types, you can see all of the columns are objects. Now here I can use something called toNumeric. So DFI amounts, I'm converting this column amounts to numeric. If I do that and I run DFID type again, then we have integer for amounts. And if I want to take a look at DFI one more time, then DFI is going to be something like this. But now everything is a number. I can apply all of that. I can make both amount and cost, convert them to numeric. So I just say DFI brackets. So like inside bracket, I'm passing in a list, and then DFI amount and cost, and then dot apply PD2 numeric. And with that being said, amounts and costs are changed, their types have changed to integers. Let's take a look at DFI one more time. You can see, you'll see that you cannot see any change, but now amount and cost, they are not object, they are integers. Let's learn a few tricks. So sometimes, for example, let's look at category. Yes, dataset category is this guy, category list. So consists of 3 integers and then 3 strings which are letters. So I can convert, for example, this to numeric as well. But I can say, for example, errors equals course. If I do that, I get null value for any time that we cannot convert. For example, for the item index 0, item index 3 and item index 4, we cannot convert LM to a number, so I'm going to get a null value here, or here, or here. Another thing is, for example, PD to numeric. So let's take a look at DFI, dataset. So I have this, and then one more time, I'm going to run this. But here I'm going to have PD to numeric, DFI category, errors equals ignore. When I do that, this column is going to be XZ itself, and then PT, and then LM. So when we say ignore, it's not going to give us null values. It's going to keep it in the original format. So this column, everything is still object. This column is D type is object. Before, in the error equals coerce, D type was float, but now D type is object. Okay. Couple of other things. For example, DFI customers .str contains li. Yeah, DFI customers, that's a series. So if you have a series, then you use .str and then contains li. You do that. Oops, sorry. And then it tells you either false or true. When it's true, it means that that specific item has li. And then here you can say that exactly the same thing. Then as type, if you do that, every time that you have true, you get value 1. Every time that you have the false, you get value 0. And then you can have DFI and then DFI customer. If you do that, you'll get a data set, a data frame with all the rows that you have. Your customer includes, the customer's name includes li. Also, if you want, for example, something that for contain, you can use, so the general format is df call.str contains and whatever word that you want. If you want it something to not contain, you can use tilde sign before the first data set for does not contain. And if you want to get, you can also use this one as well, df call.str.contains and whatever word that you have, and then equal false. That also you can use that for does not contain. Both of them works with does not contain. Nice. That was just an example that we could learn a couple of things at the same time. Now, let's move on to the next subject, working with data for date time. Now, we looked at the data set DFI. Now, with that being said, we have this DFI, and then I can make it a little bigger so it's visible. So this is DFI data set. Now, what I want to do, what I am doing here, I'm converting this date to something, a format known to Python, which is datetime format. So for that, we use pd.to_datetime. And then now if I take a look at DFI, you can see we have two date columns. The first date column is original one. The second one is the one I created. And I don't want both of them. First of all, let me show you if I check DFI types, what I will get. So if I do this, as you can see here, with the date with capital letter D, I get object. With date with the lowercase d, I get this thing, date time 64. So now I don't want the first column, date, so I get rid of that. I'm going to use drop and then in place equals true. So just drop that. Take a look at DFI one more time. You can see this data set. Yes, I have date at the end. And now I can do this as well. Say, for example, I can create year or month or day of the week out of this date object, because now this date has date time formats. I can create dfi year by saying dfi date dot apply lambda date colon date dot year. That's something that Python knows already. What does it mean? And I could also say this one, dfi year pd to date time dfi date time dot apply lambda date year, but this is just easier. I can also create month for the same reason, in the same way, and then day, and then maybe day of the week, and then after creating everything I can drop date. Let's take a look at dataset dfi. Now dataset dfi is something like this. So I have month, I have day of week. So month is what month we are at, and then I have, where's my year? Okay, that's weird. So I guess I forgot to run this line. That's why it happened. Because I already deleted dates, I have to run this again. And then after running that, I can say this, and then create year, everything, and then drop date and take a look at DFI. Now I have year, month, day. Yeah, I have everything, and day of week. So day of week is going to be a number between 0 and 6. And then dfi.info gives you what we have here. So we have integer 64 for year, month, day of week. Okay. Last topic that we have is pivots. For that, let's take a look at data sets. I'm going to create a data set df. Let's take a look at this df. I have 3 columns: name, weight, age. I have 9 observation. Name is Surush for the first 3 rows, and then for the rows index 3, 4, 5. Name is Jamie. For rows index 6, 7, 8. Name is Kian. Having that in mind, I want to see something that, so it's like 3 different people at 3 different, each of them at 3 different ages. 34, for example, Surush at age 34, 35, 36. How much he weighed? 168, 170, 173. Jamie, 120, 125, 123. Kian, 98, 102, 100. So 3 people at different ages, they weigh different numbers. Now I want to pivot that table. What does it mean? Let's run it and see. I can do this. I can have weight, use df dot pivot underscore table, and then use one thing as values. So weight is values, and then I have two indices here, index name first and then age. So I can say, now it's a little bit easier to see here, name, age, and then weight. So it's same table, a little bit different. Let's have another example. I'm going to create a dictionary called data, and out of that dictionary I'm going to create a data frame and take a look at df. So we have 4 columns, A, B, C, D. A is either red or blue, B is either 1 or 2, and then C is either X or Y, and D is a number 1, 2, 3, 4, 5. Now I can again, for example, pivot table values are going to be D, and then index is going to be A and B, and then we have columns as well. If I do that, so again we are going to have A and B, and then values is going to be this guy, 1 to 5, and then column is going to be C. What does it mean? It means that here I have one column for X, one column for Y, and now inside the table is filled with with values. So that's always true. So we have index, we can have more than one index for sure. In both examples we have two indices, but also we can have, for example, column as well. So I have column X where I have column Y. Okay, that's it. Thank you very much everybody for listening.